Hello and welcome to TGI Kubernetes. This is episode 27 and I'm really looking forward to this one. I think we're going to have a great episode going on. Is there a SpaceX? So there's already some folks talking a little bit. I see Tom says that there's a SpaceX launch going on, so let us know how that goes. That's always exciting too. But in any case, so my name's Joe Bita. I'm a founder and CTO for Heptio. Also helped get the Kubernetes project itself up and running. And for those who don't join me all the time, this is a weekly live stream where I play with something Kubernetes related, make mistakes, screw up, answer questions, interact with folks. And so that's the plan today. And I'm going to call this the Miami Vice episode because of the image that I have here of this gate that's like pink and blue and yellow. It's super cool. All right, so we have some folks saying hi. So we have Bob, who's over at Amazon now, saying hi. We have Alex from Kiev. Definitely getting a little bit late. Thanks for spending your Friday evening with me. I don't know what time it is in Kiev, but it's definitely not day. Bismarck, Fernando, Jay Hernandez from Guatemala again. Good to see you. All right. Jesse, how's it going? Good to see you, Jesse. All right. So, So my plan today is I'm going to be talking about the Kubernetes dashboard, how you, like with the security model and sort of how that has evolved over time. Some folks have been working hard on it. And then how to secure it and expose dashboards like that on the internet in a somewhat safe way. I'm not going to promise total safety, but I think we can definitely do better than just putting stuff raw on the internet. So let me say some more hellos here. So Kevin, good to see you. Nick is Nicholas. Good to see you. Are you? You're not in the office today. You must be working from home, or maybe you're with a customer today. David, Tom from New Zealand. Okay, so it's 11 p.m. in Kiev. Wow, you're staying up late for me, man. Aaron, Tim, Lamati, good to see you again. Tim, Ibrahim. So yeah, good to see y'all. All right, so so one of the things that I do when I do TGIK is I spend the first, 10 minutes or so talking about sort of what's been happening in the Kubernetes world and, and just sort of dissecting sort of new stuff that's happening because everything's moving so fast. And so let me go ahead and jump in and get started there. Okay. And so we have Juan from Argentina, Urs from Berlin, Antoine is from Paris. Good to see you, Antoine. And Ibrahim, okay, so it's midnight where you're at, Ibrahim. In Riyadh. And then Barrett in Charlottesville. All right. Okay, so let me switch screens here. So the first thing that I want to talk about, and this is totally not Kubernetes related, is whenever I do, like my favorite thing about doing TGIK is actually pulling together the images that I use for the backgrounds on the title cards. And so these days, most of the images that I'm getting are coming from this site called Unsplash. These are, it's a site where folks can share high resolution images. They're all really great, photos, lots of good stuff. And these things are shared with like no restrictions on how you use them. And so, really good for this type of thing. There's all sorts of interesting stuff here. And one of the things that I think is interesting that these folks do to help encourage people to really pick their best work is they limit the number of photos that you can submit per month. And so people really try to cherry pick their best work and get it up there. But you can see that there's a lot of really, really cool stuff. So thank you to everybody from Unsplash, both the community and the folks running the site for providing this service because it definitely makes the internet and beyond more interesting. So thank you. All right, so let's see. So let me catch up here. So we have Yash from India, Paul in Australia, Timiko is just down the hall here, Sam in North Carolina, and then Tom's reporting that SpaceX successfully deployed the payload. So another boring rocket launch. Ho-hum, who cares? All right. So the big news this week in Kubernetes world was this security issue at Tesla. And so the first thing is apparently they're running Kubernetes, which I don't think anybody had positive confirmation from, at least not publicly. and the reason we know they're running Kubernetes is because they left the Kubernetes dashboard for their cluster exposed publicly. And they did it in a way where you're able to log in and read out all sorts of information from the cluster. And so one of the things that you read out from the cluster is secrets that you've put in there to make available to workloads. So essentially, if you get access to a Kubernetes dashboard with root credentials, you can do root things like read other credentials like AWS credentials and such. And so these particular attackers didn't do anything too nasty, it looks like, but they did go through and start doing some cryptocurrency mining. And so it looks like it was the folks at Redlock, I believe, that actually discovered this and alerted them about that, and then got to write a blog post talking about what's going on. So that's kind of prompting a little bit of the topic that we're talking about today. This is something that I've had sort of been driving a lot and sort of talking about a lot, is like, how do you think about security? Folks who've been watching TGIK for a while know that I've had my own incidences where, as I've been playing with the project, they've exposed a dashboard publicly. One time I did it on an easy to type in URL, and while I was actually doing the broadcast, somebody went and started poking on that system, installed a Bitcoin miner, a cryptocurrency miner, and I was running on really underpowered nodes at the time, so it ended up breaking the cluster in a way. So this is super easy to do, especially if you're installing random software off the internet into your Kubernetes cluster. So one of the other things that if you've been watching TGIK for a while, you'll see is that before I deploy any piece of software, I go through, I read the YAML, I see what it's doing, I see if it's going to be exposing stuff to the internet, I see what kind of permissions are being given to different parts of the system. And so I think that's just good hygiene for anybody who's deploying stuff. So that's what prompted this. So this is obviously big news. Now, I think, like, reading between the lines, my guess is that they were either running an older version of Kubernetes and or they explicitly turned off or relaxed some of the protections. And we'll go into some of the details on how the Kubernetes dashboard works from an authorization point of view and authentication point of view. And so either an older version or they did something to go ahead and turn off some protections. And then beyond that, they went through and they did the extra step of exposing this to the internet. Now, I don't think any cluster setup exposes something like this to the internet by default. But because it's so easy to actually get stuff exposed with Kubernetes, it's a sort of a one-line change to a YAML file to be able to do something like this, at least with older versions of Kubernetes. And so that is... It was easier to do. It's harder to screw this up now with the dashboard, with the latest versions, but we'll get into the details as we go forward here. So Chris is saying that she also had a cryptocurrency mining happen on a cluster a while ago. Yeah, and so I think Kubernetes, as it becomes popular, it's going to be a target for people going through and scanning, looking for open dashboards, looking for open ports so that they can do stuff like this. So Eddie is in Fort Lauderdale. Aaron says that he had a Bitcoin miner on his doctor's server a couple of years ago. That's kind of scary. My wife's an MD. They don't have any servers though. Everything they do is cloud-based, and so no servers there. And then Sankit's in Naperville, Illinois. And it's near where I grew up. All right. So other stuff happening in the sort of Kubernetes world is so our friend Jess, who was online earlier, maybe she's listening, maybe she's not. She introduced this really cool tool, or at least started talking about it because she's been working on it for a little bit now, called Image. Chris says they don't have any servers, never true. Well, they don't have any servers that they admin themselves. All right, let's just put it that way. My wife's doctor's office is serverless, so you can quote me on that. And so. Yeah. So okay. So Jesse's here, but she's hiding. She says. So this is really, really, really exciting. So right now, so just when you build a Docker image and you do Docker build, what that ends up doing, it ends up taking all the data in your current directory, tarring it up, sending it over to the Docker daemon that's running as root, and then that whole flow of actually building the thing happens in the Docker daemon. And this is just sort of, I think, in some ways, an accident of history of how Docker was built. So the upshot of that is that building a Docker image is really entwined with Docker in a sort of fundamental way. Now, the Docker folks have been working over a long time to sort of take the pieces of the Docker daemon and sort of explode that out into a bunch of different sort of projects, one of these being build kits. I haven't used it directly, but there were a couple of things that happened here. Is that number one is that to build something, you had to talk to Docker directly, and that this needed root privileges because the Docker daemon runs as root. When you want to start doing something like build a container on a Kubernetes cluster, you're really stuck in a bad position because you either have to do a Docker and Docker type of thing, and to do Docker and Docker, you have to turn off a bunch of security protections, or you have to essentially give the workload that's doing the building access to the Docker daemon that's running on the server. And so you're essentially reaching around Kubernetes and talking to Docker directly. And so that means that all the sort of quota and protections and everything that Kubernetes does to apply policy on top of Docker, you're throwing that all out the window when you give that direct access to the Docker daemon. And so there is no great solution right now in terms of what it takes to build a container on top of a Kubernetes cluster, at least using the Docker model. And so there's a couple of projects that have started pointing the direction to sort of breaking these things out into sort of more sort of plug and play componentizable thing. And this is the one that Jesse's been working on. But the super duper interesting stuff for this one is that Jesse's working hard to make it unprivileged and daemonless. And so this means that as this stuff continues to move forward, and I talked to Jesse about it a little bit, and the unprivileged mounting stuff is a little bit shaky. But as we continue to work on this, and by we, I mean Jesse and other people, as folks continue to work on this, we're going to get to a point where you can actually build containers on top of Kubernetes, on a Kubernetes cluster, in a super clean way. And I think that's really, really exciting. I guess there's a third way that you could build it, and that would be to run a virtual machine inside a container and then run Docker inside of that and use that to drive things. So that's totally, I don't know if anybody's doing that or not. That'd be an interesting way to do it, maybe like a clear containers type of thing. All right, so let's see. So Sankit says, we had an AWS workshop 4 months back, and someone committed these access keys on GitHub. Yep, that'll happen really fast. I know folks like GitHub and Amazon continually scrape people checking stuff into GitHub looking for things that look like access keys or OAuth tokens or stuff like that. Jesse does write the dopest software. This is true. And then, yeah, so Jesse's saying it's kind of rough right now, but we're making forward progress. And I think a lot of times in situations like this, once you can start seeing the pieces come together, then it's just a way of chipping away at the problems that are left. So I'm really, really excited to start seeing these pieces come together. So the next project I want to talk about, I haven't played with this one yet, but I was pointed at it from the folks at Vapor.io. They're doing this edge compute type of thing and using Kubernetes to do it. I think they sell edge boxes to some degree. I don't want to make too many assumptions about what their products are. I haven't looked deeply, but this is a file system synchronizer into a container, and so it's for development stuff, especially for dynamic languages like Node or Python or Ruby, where you can use your editor locally, and then as you save stuff, it gets mirrored up to stuff that's running in your cluster so that you can shorten the debug loop. And so this is something that I really, I'm super interested in, because I think that bridging the gap between sort of the development process and the deployment process of what you run on the cluster is super interesting. So I think this might be something that I want to do a future episode of TGIK on. Let's see. And so Aaron's saying, we recently launched something called CredScan, where we monitor GitHub for anything that looks like one of our secrets and notify the customer. Yeah, totally interesting. And Barrett says, bye-bye Docker sync. I haven't used, is this the Docker sync that was used for local Docker sync because the mounts were so slow? I know that there were it was using this like super old, like, synchronizing thing called synchronicity. This looks really interesting though. So I want to dig into this. This looks really cool. So there's that. And if folks have a chance to play with it before I get to it, definitely, reach out on Twitter and let me know what you think of it. So the other thing, and somebody on Twitter, and I meant to write the name down and I didn't, pointed me at this talk from KubeCon in Austin. And this is Brad Geesaman from Symantec talking about hacking and hardening Kubernetes. This is, I missed it when I was there, but I watched it prepping for this. And this is actually a really good introduction into some of the low-hanging fruit of what we need to do to actually secure Kubernetes. And if you go through, let me find I think this slide, let's see. This slide I think is really interesting here because I think one of the lessons that we're going to talk about here is that there is like a lot of the security features that we started adding. We really started in 1.6 and we've been continually to improve things. And so, Fernando, it was you. I'm sorry. I let that go. It was Fernando who tweeted this at me. Just to use his language. So Fernando tweeted this at me. So thanks, Fernando, for that. Let's see. And so starting in 1.7-ish is when we really started adding a lot of the security hardening for Kubernetes. And so, this is one of those things where if you're running something pre-1.7, you have to be much more careful about hardening things and sort of isolating the cluster. Over time, we're going to be continuing to lock things down and provide more and more features. Okay, so let's see. So in the spirit of the Olympics, I'm giving you a gold medal. Thank you for that, Fernand. We had Fernando sent me the link. It was Fernand here who's asking about this. Speaking of secrets in GitHub, what are your thoughts, experiences with Gitcrypt to stow away creds? I haven't used Gitcrypt. One of the other things, though, that I think is interesting for storing this credentials is this thing called, oh God, what is it called? It's a Bitnami project. And this was Gus's project where it's like encrypted secrets. A Bitnami encrypted secrets. Sealed secrets, that's right. Oh, it's Bitnami Labs because they have labs. Everybody who's cool has labs. So this is Gus's thing. And so this is actually a really interesting way to actually deal with secrets. You essentially encrypt stuff, check them into Kubernetes, and then there's as you apply these to your cluster, there's a controller that has the decryption keys that decrypts them in the cluster so that you never have to check them into your cluster, but yet you can still use things as you always use them. So it's a really interesting project there. So I haven't used, but with a name like Gitcrypt, I think maybe it's similar to this. But here we're actually doing it with decrypting at cluster time, not necessarily using something like a Git hook. So that's actually pretty cool. All right, so sealed secrets, yeah, so y'all are way ahead of me. And it says, does Sonaboy take security best practices into account? Not yet. That's something that we're looking at super carefully for sort of enhancements to Sonaboy. And so, essentially, as soon as we saw the testless thing, I sent a Slack message to Tim saying, hey, we need to make sure we get this into Sonaboy. And he's like, file an issue. I'm like, okay, Tim, I'll go file an issue. Yeah, and then let's see. Yeah, Sean says, I've used Gitcrypt before and it's okay, but I've only used it on an internal Git server at work. So yeah, I have no experience with it. And then Kelsey will do no security. No, I don't think no security. Well, if you have no code, you have no security problems. It's like, mo code, mo security problems, right? All right. So the next thing, this is a tease here, is Dave Cheney is working on a blog post, and let me just, which is how to deploy using Contour, Let's Encrypt, and the JetStack cert-manager stuff. And so the cluster that I'm going to be working with today has cert-manager set up with Contour. to be able to serve HTTPS, which really ends up being sort of min bar as you start exposing stuff to the rest of the world. And so, so this blog post is not out yet. It's coming, and we're giving some feedback to the JetStack folks to actually make the cert-manager stuff easier to install, more streamlined, and so working through some issues there to make sure that this stuff is as seamless as possible. Yeah, so Equifax already did no security. Yeah, well, don't throw stones. It's only a matter of time before, it's like everybody can screw up. Well, I don't. All right, so with that said, what I have here starting on, let's see if I'm still logged in. What I have here starting out, so we're 20 minutes in here already, is I have a Kubernetes cluster using the Heptio quick start, because that's my go-to thing. And then I've taken that cluster and I've installed Contour and I've installed cert-manager on that with Let's Encrypt. So we can go ahead and create certs and get things up and running. I've also gone through and I have a star.tgik.io is pointed at the ELB that Contour set up. So I can do all sorts of stuff like that. And then Dave's tutorial has you go to, he has you install HTTP bin. And so if you do http://bin.tgik.io, you'll actually see that this thing is up and running. So we got that all up and running and it's happening and it's all nice and secure. So that is sort of where we're starting from here. And so the first thing here, and I have sort of a set of notes that I'm going to be going through, but kubectl version, I can look at that. You can see I'm running a 193 cluster and a 192 client. I can do kubectl get nodes, and I think I have 3 nodes and a control plane node. So pretty much empty-ish cluster. Fernand says, are you using cert-manager Helm chart or straight up Docker? We're using the YAML that the cert-manager repo has checked in under its examples. That YAML is generated from the Helm chart, and there's some, and one of the things we're working with is making it so that works easily out the gate. I think Helm is a whole nother ball of wax from a security point of view. There was, and I meant to actually find this. Lockie had some great slides. I'll dig those up and I'll post those later because I don't want to go searching for them now. But Lockie had some great slides that he had at the Helm Summit, which was just this last week, talking about how to secure Helm. And then another good reference is Gus, who did the sealed secret stuff, dug into some of the details of some of the things you really need to be aware of as you use Helm from a security point of view. I didn't want to sort of layer on more security stuff to talk about in this particular talk, and so I did it without using Helm. Okay, so, all right, so here we go. So the normal thing that people do when they want to get to the dashboard is they call kubectl proxy. And, so Mark's asking, what is the cloud formation that I'm using? So if you search for Heptio Quick Start, you'll get to this thing. This is an Amazon Quick Start, and this is a one-click bring up a single master, single zone Kubernetes cluster. This is something that was one of the first things that Heptio did, and we've been continuing to keep this up to date and improve it. Yeah, okay, so Lamatti's cat is super interested, so that's good to know. Thank you. All right, so that's the cluster that I used to get up and started. Okay, so most of the time what people do is they do kubectl proxy, and what this does is this essentially creates an HTTP proxy that gets hosted on the API server that then forwards all stuff to a particular node that's running, and as it a particular service, and as it does so, it sidetracks a bunch of the sort of networking gotchas that happen. I believe this uses like a port forward type of thing. So the traffic, when it actually hits the pod, when it actually hits the dashboard process, looks like it's coming from localhost when you're doing this stuff. To localhost to the pod, I believe is how it works. So let's go through, and so if we click on this, if we go to like localhost 8001, what you'll see is this is essentially what happens when you hit an API server, a Kubernetes API server, without doing anything else. And you can see I can do version, stuff like this. Now, as I'm doing this, I'm talking to the API server directly. And one of the things that, actually, no, I'm sorry. So this talks to the API server. And one of the things that it's doing is it's using the credentials that I have in, that I use for kubectl to actually, essentially do this browser. And so anything that I actually hit here from the Kubernetes API point of view will be using those credentials. So this is essentially a credential stamping proxy as things go. Now, one of the things that you'll see is there's this shortcut here. If you do UI, it does a redirection here. And it does a redirection to this particular URL. And so what this says is we have API v1 namespaces kube system services, and then it says, well, I want to go to the HTTPS port of the Kubernetes dashboard, and I want to proxy to that. So this is a way of essentially talking to a service and proxying to it. This is a, and so this type of URL works for any service that you might want to proxy to. And this does some wacky stuff as it goes ahead and does this. It actually looks at the stream of content coming back for things that look like URLs, and it does active rewriting of those things so that they get hosted at this sort of like base in a reasonable way. And so now, because the way that we set up, and I encourage everybody, when you can, we're using a kubeconfig that uses client certificates to authenticate to the API server. The dashboard itself doesn't know how to actually, that you can't forward that because that's actually one of the features of using mutual TLS and public key encryption is that I can authenticate me to somebody, but then that person, that entity on the other side, that server on the other side, can't then go ahead and impersonate me to somebody else. And so it ends up being a point-to-point type of authentication versus a token where if I give a token to something, somebody can easily go off and take that very same token and hand that off to somebody else, right? So the feature of PKI is that it's harder to intercept and do like a man-in-the-middle attack, hard/impossible. But what that means is that there's no way for the API server to take my credentials and then forward those credentials to the dashboard so that the dashboard could use them. And so if you show up at the dashboard with no other type of credentials coming through, with I think this is 1.7 plus cluster, you're going to get a screen like this. This is a login screen. And all the details that talk about this, and I'll put all these links in the show notes, are here that talk about sort of what happens with different clusters and sort of what the default permissions and stuff are that they have. But what you'll see here is that you have this login view. Now, what you can do with the login view is you can give it a token, or you can upload a kubeconfig. And the kubeconfig is just a shortcut for extracting the token out of your kubeconfig. If you have a kubeconfig that has non-token based auth, that has authentication based on public keys, you can upload it here, but it won't work. And then if you go through and if you hit skip here, what happens is you talk to the web UI, but the web UI uses its default service account to be able to talk to the rest of the cluster. And what you're going to find here is that at least in more recent clusters, that service account is really locked down. And so if you don't give the dashboard any sort of credentials, the dashboard has no credentials to work with. All right, so what that means is that so far the default setup in sort of like a 1.9 cluster that we have here in a more recent cluster is actually not too bad. It's actually in pretty good shape. You need kubectl proxy to even get to the thing. And once you get to the thing, you need a way to actually give it credentials so that it can act as you. So that's where we're at right now. So now the problem here is that a lot of people hit this and they're like, man, that's a pain in the butt. Because security often is a pain in the butt. And then they start searching Google saying like, how can I make these warnings go away? And there are hammers that you can bring to this thing to make these warnings go away. And they're ill-advised. So let's do one of those ill-advised things. So don't do this right now. So Bismarck's saying is that you can also pass a token with the authorization header. So, right, so that's something that we can get to later is that if you don't want to use that login page that we had earlier, you can go through and configure something to pass a header to this, and it'll actually then pass that header through to the API server. Still, it's token-based auth, but you can do that with a browser extension to add that, or you can do it with a proxy in front of it that actually stamps that thing on there. All right, so let's go ahead and use one of the bad hammers. So what I'm going to do is I come up here and I'm going to have Kubernetes dashboard no access. I'm going to search Google and let's see, we have this here. So this is the page that I came up with, so that's good. And so then if you go down to the bottom of this page, you'll see like here's a hammer that you can use that says put this stuff in a file and go ahead and add it. And so let's do this. Don't do this, all right? I'm going to do it, but you all shouldn't do this. So I'm going to do the Control-Z background with this thing. And then if I bring up here, these are my notes. I'm going to have this. I'm going to put this in there. And this is, I'm not going to upload this to a gist that I create after the fact. We're going to create this, and this is admin dashboard.yaml. All right, so if we look at this, what this is doing is this is creating a cluster role binding. What it does is it says the service account, so this is the subject, the Kubernetes dashboard service account in the kube system namespace, I'm going to give it cluster admin, which says give it root. So this is kind of like a sudoers file. It says like, hey, I'm going to give my web UI root on my machine. So let's go ahead and so now we have this thing called admin dashboard, and we can go through and we do kubectl apply-f admin dashboard. We go ahead and do that. Now if I go back and if I refresh, look at that. Everything's working. It's amazing. Boom, done, fixed. Okay, that's great, but now the problem is that if anybody can actually get to this dashboard, they can act as root. And so you're one mistake away from exposing this to the rest of the world and creating a problem. Now, the next thing is that I can go through, and if I go through and do kubectl get, let's see, I have an alias here for alias k8s equals kubectl and kube system. So we'll do that. k8s get pods and k8s get services. You can see that we already have a service for the Kubernetes dashboard. And I can do k8s edit service, or I can edit or recreate this. And then I can go through, and if you do something like type equals load balancer, this will actually go off and create a publicly accessible load balancer. If I were to do that, yeah, I would now all of a sudden expose my dashboard to the world. Now, it turns out that there's another block here, and this is probably something that I think is a default in 1.9, where it applies network policy on top to block out the dashboard also, just because the current policy around this stuff is super paranoid. But you can see how people can easily, via changing a couple lines here and there, expose their dashboard to the rest of the world without being super careful about it. It's gotten harder over time, but it's still way easier than I think most people suspect it should be. So I'm not going to go ahead and change that. I'm going to go ahead and close this. And then I'm going to go through and I'm going to So like now I have full access, and you can you can not only just read stuff, but I can go through and start reading secrets and stuff like this. And so these are just reading, you know, let's see. So, you know, I can read here's the certificate for the HTTP bin service that I had, right? So you can start reading TLS secrets and all sorts of stuff out of this. And it's not uncommon for people to put AWS secrets in here, so that's bad news. All right, so let's go through and let's delete that that policy that we had there. So we had apply the admin dashboard thing. We're going to go through and we're going to go delete, and that's going to delete the cluster role binding. Now if I go back and if I refresh this, it's going to give me an error. All right, so don't do that. I undid it. That's not what we want to do. Now, if I go back to the login screen and I go hit sign in, let's say that I do want to actually get a token that I can put in here. So this is sort of a more safer way to do this. Now, if you're using a different kind of auth system with Kubernetes, you may already have a token, in which case you can upload the kubeconfig or paste the token in there, or configure a browser extension to go ahead and put that in the header as you actually send it to this. But if you're like me and you're running in a cluster that doesn't have a token, you're like, well, how can I go ahead and get a token? And out of the box, there are 3 ways without installing some sort of extra type of authentication for Kubernetes. There are 3 ways to get tokens to authenticate. The first way, and this is kind of a legacy thing that most people don't use anymore, or actually, no, I think there's 2 ways to get a token. So one of them is a bootstrap token. Generally, these tokens aren't used for anything besides bringing up a cluster. And the second way is service accounts. Service accounts, as you create them, create tokens. Right now, those tokens are long-lived, and it's not uncommon for people to extract those tokens, put them someplace, and use them. We're in the process of rethinking about how we create service account tokens so that they are created on demand at the node level, and they're more scoped, and they get rotated and that type of thing. That hasn't happened yet, so right now I'll show you how to create a service account for doing this stuff and get a token from that. And then the other way authenticating it is username and password. I think there's a token way. These are files that are laid down on disk at the API server, and if you change these files, you have to restart the API server to be able to update things. I believe there's a token method there, and then there's also username and password. And you can set up the dashboard so that it'll ask for username and password and then pass that forward too. I'd recommend that folks don't use those files that are on disk. It's super brittle to change those things because you have to like edit the files on disk and then restart the API server, and it's difficult to keep those things in sync if you do any sort of HA type of thing. All right, so I did this before, and I think I forgot to actually delete the service account that I created. But if I look at my notes here, let me go ahead and delete these. Kubectl delete. So that's my dashboard essay. My dashboard essay. I think I forgot to. There we go. Okay, that's deleted. And then I had a cluster role binding. Now you can do these things with YAML, or you can do them sort of in an imperative way with kubectl. But, so the first thing I want to do here, so pretend I didn't have that there because that was left over from before, is I create a service account. So I created a service account called My Dashboard Essay. Now the service account is in the default namespace because that's how my kubectl is set up right now. So I can do kubectl get essay, and I'll actually see I have the default one, which is available in every namespace. And then I have this new one called My Dashboard Essay. And then I can go through and I can create a cluster role binding. And so this is essentially saying that across the entire cluster versus like the non-cluster role binding, which is a namespace role binding, I want to use the cluster admin role, and I want to give that to the My Dashboard Essay service account in the default namespace. And so that's what this sort of syntax here means. So I go ahead and create this, and now I've said, okay, I've not only created a service account, but I've given that service account root on my cluster. So that's a pretty powerful service account. And then the next thing I can do is I can do kubectl get secrets. And what you can see is that we have here this thing here is my dashboard SA token dash M4J2B. So there's a controller in Kubernetes that looks at service accounts, and as service accounts get created, it creates a secret that gets paired buddy-buddy with that service account. And inside that secret is a token that I can use to talk to the API server. So now if I go through and do kubectl get secret and dump this secret, you can see that there's a couple of things here. There's the CA bundle that I want to use to talk to the API server. There's which namespace this thing is for. And then there's this long thing here, which is my token. Now, this secrets are base 64 encoded. So now what I can do is I can copy this and, oh, actually, no, if I do a describe secret on this, describe secret, oh, that's not. I'm going to copy and I'm going to paste that into the login screen. And for astute readers, you'll notice that this is actually a JWT. So actually, let's go through and explore what this token looks like. So if you go up, so if you go through and if you go to jot.io and you can go through and I can put this in here and it decodes it for me. And what you can see is that this is a RSA 256. That's the algorithm used. So it's a public key type of thing to actually sign this jot. And the information in the jot is that this is a service account for the default namespace. And here's the name of the secret that holds it. And here's the name of the service account. And here's the UID for that. So all sorts of information. And then here's the signature stuff. So you can take that token, which is a jot, and decode it and actually start seeing a little bit of data behind it. Okay, so now we're going to take that thing that's in my paste buffer here, and we're not going to upload a file. We're going to paste that in here, and now I'm going to go through, hit sign in, and everything's going to ask me if I want to save that. And look at that, woohoo, I actually now have access to this. Now this is strictly better than what we had before. And the reason why it's better is because if somebody accidentally gets a network path to the API server, I mean to the dashboard, they'll be able to they won't be able to do anything because the dashboard itself now has 0 permissions. Now, that doesn't mean that you're now safe to actually expose the dashboard to the world, because there could be a bug in the dashboard that lets you compromise it. And if you can compromise the dashboard, you can sit there and then you can capture other people's tokens and act for them, right? So you still don't, like, there might be a bug in the dashboard that you want to protect against. So I still wouldn't go ahead and put this sort of open to the world. And I think we see this with, you know, systems like Jenkins, which are super complex, where, you know, it's still probably not best practice to take Jenkins and only trust the Jenkins authentication if you expose it to the rest of the world. There have been issues with that in the past. So Lamati says, any suggestion for using two-factor auth, Authly, or Duo with the dashboard? I don't know of anybody who's doing two-factor auth. I think one of the things that you can do is you can authenticate to the dashboard. The dashboard then takes that token, sends it through the API server, and if you have access to muck with the command line flags of the API server, you can actually do a webhook type of thing to verify your thing. And so you can actually do two-factor auth and expiring tokens and all sorts of stuff for actually getting to the dashboard. That's a pretty advanced use case. We're going to get close to that, but we're not quite there yet. All right, so this is probably, you know, pretty state-of-the-art in terms of locking this stuff down. It's still not great because you have the service account. The service account itself is kind of a shared thing. You really want to have things as much as possible be locked down to an individual user, whereas anybody who has access to that namespace or sort of broad access to that namespace can get and read that service account token. And so it kind of hides the attribution of who's doing what, when, and where. But this is not bad, right? So this is a sane way to do it. The kubectl proxy plus the token like that. And you can obviously do something like the browser extension to eliminate that login screen. All right. But the next thing is like, well, I don't want to do a kubectl proxy every time I want to talk to the dashboard. That's a real pain in the butt. So, so let's go through, let me look at my notes here. So one of the things that, okay, so one of the things that we're going to do next is try and expose this to users. So you don't want to do it directly. You could expose it with node port, and if you do it with node port, then anybody who has access to any of the nodes in the thing can actually get to in the cluster can actually get to the dashboard. But a lot of times when you're running in the cloud or when you're running on-prem, there's like a sort of, you don't have direct access to these things. And a lot of times in sort of more traditional enterprises, you'll have like a corp network or you'll have sort of an internal network and you'll be able to VPN into that, and then you have direct sort of IP routable access to your production machines. The trend, and Google's been working on this for a long time, is to start to eliminate and shrink and not trust the idea of a corp network. Because the truth is that we all have cell phones and computers and so, and if any one of these machines is compromised, you've essentially compromised your corp network. And so at any sort of scale, you just assume that the corp network is already compromised. And so one of the ways that you can do this is that you can run a proxy, an authenticating proxy, in front of your workload. And that's what we're going to do. And there's a whole host of these. I'm not an expert here. Barrett's here saying that the Google Identity Aware proxy is really nice. And Somya is saying, any idea why cAdvisor is decoupled from the kubelet starting 1.9? How do you suggest we get the usage info into k8s dashboard going forward? I think cAdvisor is built into the kubelet, my understanding is, but you need to, but you still need to run Heapster to collect that data. And so you need that to be able to get at this data. I believe that's where it's at. Yeah, and so the Beyond Corp as a service thing, the identity aware proxy, is one of those things that Google's been pushing. I haven't used it. I don't know how well it integrates with GKE. The thing that we're going to be deploying now is, let me find it here. There's improvements coming to all this stuff, and so like the dashboard team's not done. There's a checklist of things that they're looking at here, with things like native support for external identity providers, that type of thing. There's still the question of then how do you actually pass that identity into core Kubernetes, and so there ends up being a sort of tight configuration coupling between the dashboard and Kubernetes in terms of the way you auth to the dashboard. How do you then go ahead and use that with Kubernetes? And because Kubernetes authentication is so flexible, it really gets a little bit tricky to be able to make this sort of secure and easy and working by default. It's a hard problem. It really is. So the proxy that we're going to be working with is this project from Bitly called the OAuth 2 proxy. And they have some nice handy-dandy diagrams here. The one that we're doing is going to be similar to this, to the one on the left. There's sort of two scenarios that you have here. So what we have here is the user is going to go through, talk to, instead of Nginx here, we're using Contour and Envoy. So this is going to talk to Contour ingress. That's going to do SSL TLS termination from stuff coming from the web. It's then going to go ahead and forward that to the OAuth 2 proxy, which is this project here. That's then going to go coordinate to actually confirm your identity with an auth provider. We're going to be using GitHub in this example. And then if you pass muster there, if you're able to authenticate, and there's ways to specify which users, you could do something like anybody who's joined to a GitHub org, or if you're using Google, you can use a Google group to actually authenticate stuff. So you can manage some sort of allow list there. But if you pass the allow list, then this goes ahead and proxies to the upstream service. And so it essentially becomes a discriminating proxy to the upstream service. And then there's options whether you want to go ahead and take the token that you got from the auth provider or information about the user and pass that through. So we're not going to take it all the way. There's some really fancy stuff that you can be doing here, but we'll at least get this as a sort of safety screen in front of the dashboard. So David Anderson says, can you use RBAC as an allowed list and OAuth 2 purely to bind an external identity to the k8s role? Now that's a really good question. So there's a new call in Kubernetes, and I don't have the timeline of when this stuff has become available, called subject access review, where you can essentially say, hey, this user wants to access this resource. Are they allowed to do that? And I think it would be possible to actually use subject access review to have the OAuth2 proxy defer to that for who's allowed to actually be let through versus not. And you could create some sort of, maybe use a CRD or some sort of like synthetic, resource to be able to do that. I don't think the OAuth2 proxy supports that natively, and I think it would have to start integrating with Kubernetes and have its own permissions to be able to call subject access review. But I think that might be an interesting way to do this. No, so that's not there. The interesting thing is that you can't walk up to a Kubernetes cluster and say, what are all the users who are authorized to the Kubernetes cluster? Because Kubernetes just says, well, if I get a token or something, let's say token, for example, I pass that off to somebody, they tell me what user it is, and then I trust what they say. And so that set of users that Kubernetes is able to recognize is actually unbounded. And it's really, the job of the identity provider to actually decide which set of users it returns. So the idea of using RBAC here is I think a sane one. I don't think it does it right now. Okay, and so because we have to do this TLS termination here, that's why I set up Contour with Let's Encrypt and cert-manager, because that at least gives us table stakes in terms of being able to get this thing up and running. Okay, does that make sense from a diagram point of view? So the first thing we need to do is whenever you're doing an OAuth flow like this, you have to go to the OAuth provider and you have to say, hey, I'm a new application. So we're viewing this thing as an application that wants to partner with GitHub for being able to do identity. And so if I go down here, we're going to follow the GitHub instructions, and then you create a new project. They call it projects or applications. Actually, let me go through and launch this in a new thing. And so you go to GitHub and you get a screen like this. Now I created a special user here, JBeta TGIK, because I didn't want to confuse things with a bunch of random stuff that might be there. We say register new application. So we're going to call this TGIK dashboard. The homepage URL, https j.hep.io. TGIK. This is just informational. So this is all context so that when somebody is presented with this screen saying, hey, do you want to trust this application? There's some level of who the heck is that application? Because, when you start looking at the threat models around OAuth, typo squatting and sort of lying about who you are is one way to steal credentials. TGIK, and then the authorization callback URL. And so one of the ways that you lock this down is that if somebody goes through and does this flow, there's a redirect that happens from the OAuth sort of authorization page, and that redirect has to GitHub will only redirect to a URL that you configure here. So it's another way of locking down OAuth. And so what we need to do is it's going to look something like this. And let's see, what was I going to call this thing? I have to, k8s dashboard, I think. I have a whole pile of YAML here, but I forget what the domain name that I was going to use was. k8s dashboard.tgik.io. Okay. So this is what we're going to call there. Okay, so this is k8s dashboard. So now I'm going to go ahead, I'm going to register this application. And as I do this, what you can see is that you can put a logo up here. You can do all sorts of things. Interesting thing is that it's a single person that owns one of these things with GitHub. And so if you're a company and you're worried about somebody quitting or leaving and losing track of this stuff, this is something that you want to be aware of. This is not owned by an organization. It's owned by a person, which is kind of interesting. And the two things that I want out of this is the client ID and the client secrets. So now what I'm going to do is I'm going to take these, I'm going to put these into a Kubernetes secret so that we can reference them as we go through and reference these as we actually set up the OAuth2 proxy. And so I have here a command line to be able to create these things. And so these are some previous run that I had here. So the client ID I'm going to put here, and then the client secret I'm going to put here. And then then the other thing we need is we need a random cookie that's used to actually sign tokens that the Kubernetes dashboard is setting, cookies. And so this needs to be a random value. And so we're using a little sort of Python subprogram here to be able to do this. So this becomes a one-liner when I run this. well, I guess, logically a one-liner. When I run this, it outputs the YAML for a secret that I can then upload and apply to my cluster. I could upload it directly, but I think generally you'd want to maybe use something like sealed secrets to be able to store this type of thing in GitHub. So now I go through and I have a pile of YAML here that I'm going to go through OAuth proxy, but one of the first things I have here is the data for my secret. I'm going to go ahead and put that in there. Okay. So let's go through the YAML that we're going to be setting up here, and I'll talk about which each of these resources is and how they relate to each other. So the first thing I have here is I have the secret. This is the Kubernetes dashboard, OAuth secrets. This is the information that the OAuth proxy needs to do its job. It lets it identify itself to GitHub, and then it has the data that it needs to be able to sign things so that it knows that nobody's trying to spoof a cookie to it. The next thing I have here is I have a deployment for the OAuth 2 proxy itself. So Lamandi says, where can we find a list of authentication providers? Curious what solutions are available for on-prem k8s installations. We are highly regulated and can't use external authentication sources. That's a really good question. I think you can be as flexible as you want to be with Kubernetes. Kubernetes authentication is really a whole nother ball of wax. Most of the time, people will use something like LDAP, Active Directory, or OpenID to be able to do this. I would look at something like DEX as being sort of a intermediary here that gives you a way to start bridging stuff. And one of the things that I want to do in a future episode, and we have a project that we're going to be open sourcing that's going to help make this stuff easier, is demonstrate how to install a custom auth provider into Kubernetes. And I'll probably end up doing GitHub again, but you'll see some of the same techniques, and we can talk about other ways of doing stuff. So yeah, Tectonic is one of the sort of the authorization. So Sean says we use Tectonic, which has integration with Active Directory and has its own dashboard. So yeah, so the non-dashboard part of Tectonic is this system called DEX, D-E-X, that CoreOS has open sourced. And so you need that, plus you need some sort of dashboardy type of stuff to be able to actually play the sort of dashboard role. And so I'm hoping to be able to show something there that'll actually get you up and running without having to necessarily do something like Tectonic. All right, so now we have a deployment here for the OAuth proxy, and so this is all relatively sane stuff. The cookie secure thing here, this is set to false. This was something that I cargo-culted from something else. I don't know if this can be true or not. I haven't had a chance to check it. So you'll have to forgive me. I suspect that we could get away with this being true, but I'm not sure. I just haven't had time to try it. We're saying we're using GitHub. This is the upstream. So this is the thing that it'll proxy to. So if we go back to the diagram, what we'll see here is whatever this server here that's sitting behind the proxy is called the upstream service. So David says DEX only bridges to another OAuth 2 provider. It won't let you build an on-prem auth provider. It will bridge to LDAP and Active Directory, David, I believe. And then Keycloak, which I'm not familiar with, also provides an OIDC interface that can be delegated to multiple ID providers. One of the things that I'd love to do is actually do a Kubernetes native OpenID provider so that you can actually have something like custom resources to allocate users along with passwords and stuff like that, so that you can actually get to the point where you could install a user database into it. But most people will defer to some sort of SSO type of thing as they're setting this stuff up. But nobody, to my knowledge, has built a sort of Kubernetes native ID provider. Okay, so HTTP address, this is what this thing is listening on. The redirect URL, so this is the thing that when this thing redirects people to GitHub to sign in, this is the place where we want things to call back. And you'll see that this lines up with the authorization callback URL here. So these things are the same thing. So we have to make sure that those are aligned. So David's saying, Ori Hydra is what I was thinking of. Okay, I'm not familiar with that, David. So yeah, unfortunately, I couldn't figure out a way to let people post links in YouTube. I was trying to do that when Chris was doing it last week, and I don't think there's a way to actually let you all post links. All right, so, and then we're saying we're going to allow any domain, but we're only going to allow people who are part of the TGIK organization. And so I created an org to go with this also. And so that's all we need there. And then we're going to set the secrets here. We're going to import those things from the secret and put those into environment variables. And so this is all documented in the OAuth2 proxy site, except for this cookie secure thing, which wasn't documented well, and I haven't had a time to really dig into that. All right, so this is relatively straightforward. This thing's going to be listening on port 8080, and so that lines up there also. One of the interesting things to keep in mind is that this is actually doing HTTP upstream. So the connection, let's see, going back to our diagram. Oh, that's not. Okay, so this arrow here in our setup is not TLS encrypted. And the reason being is that by default, the dashboard does do TLS encryption, but it does it with a self-signed cert. And there's no way to that I could find with the OAuth2 proxy to essentially say, here's an extra CA that I want you to use for the upstream provider, or to say use HTTPS but ignore validation errors on the certificate. So we're just defaulting back to regular old HTTP here. Keycloak is used as part of OpenShift, if I'm not mistaken, so it's similar to Dex and Tectonic. Okay. All right, so this is going to run the dashboard. We got the secrets and all that. I mean, running the OAuth2 proxy, and now we have to actually get everything else plumbed in. So we're going to have a service to the OAuth2 proxy. So this is a regular old Kubernetes service, and then we're going to set up ingress to this thing. And since we're using certificate manager and we're not doing this sort of super duper cute thing, this is essentially saying I want to go through and do an Acme, let's encrypt prod thing for that Kubernetes dashboard. And then I'm going to set up ingress. We're using Contour here as our ingress controller that says everything coming into k8s dashboard is going to use this TLS certificate and redirect to the Kubernetes, the OAuth2 proxy, and we're up and running. So I'm going to put this all in a gist that y'all can see after the episode here. But this should be relatively straightforward here. So let's go ahead, and I'm running all this stuff in the kube system namespace. If you want, you could always put this in a different namespace. There's no reason that you couldn't. So kube control apply -f OAuth proxy.yaml. And so if we do this right, then if I go to k8s dashboard .tgik.io, look at that. It says sign in with GitHub. I click on this, and what you'll see here is that it's saying, and this is the screen, this is why you want to put an icon there, and this is where it says here's where it's going to redirect to, and it tells you about the application and stuff like that, and sort of who owns that application. So, if you're a user and you see a screen like this, you want to be very careful to make sure it all makes sense, because you're essentially granting something else permission. But right now we're like, well, we're not going to give it that much permission. The one thing you do, since we're checking against the TGIK organization, is we do have to grant that organization here. I do that. I go ahead and hit authorize, and it doesn't work. And that's okay. That's okay. It took me a while to figure it out, and it wasn't until 11:45 today when I figured out what's happening. And this is part of some of the lockdown that people have been working on for the dashboard. If I do get network policies, what you see is that there's a policy here called deny dashboard. And so what this says is that nobody's allowed to talk to the dashboard. My camera went blurry. There we go. So what we're going to do here is we're going to neuter this policy. We can look at locking it down to just the OAuth2 proxy in the future. But let's go through ksys edit network policies deny dashboard. So we're going to go through, and the way that you do this, and I am not super duper familiar with this, but so it says upstream request timed out, because what happens is that network policy prevents our OAuth2 proxy from talking to the dashboard. So again, in modern versions of Kubernetes, you have to try really hard to be able to expose the dashboard. We're having to sort of remove multiple roadblocks here. So Kubernetes network policy. All right, you all are getting 403s. All right, I knew as soon as I put this out there, people were going to start hitting it. One of the things we'll do, though, is I'll go through and, when we get further, somebody can put their GitHub ID up there, and we'll actually try and see if you can get through. Let's see. So here's all the stuff, and what we can do is we want to do default allow all ingress traffic is we want to do this spec ingress, and then say that's essentially saying everything can ingress in. I go ahead and I close this, and that works. And you'd think that would be good enough, but it's not. And the reason why it's not is because, remember, we were hitting the dashboard. We were hitting the dashboard and on an unsecured port, right? Because it's a self-signed certificate. If we were going to make that link between the proxy and the dashboard secure, and the auth2 proxy doesn't know how to deal with that. So one of the things that we'll see here is that if I do edit Kubernetes dashboard, we'll see that the service. So if I go ahead and I edit that, what we'll see here is that we're only exposing port 443 in the service. So we have to expand the service a little bit to be able to expose another port. But off the top of my head, I don't know what port that is. So this is as far as I got. So we're now in uncharted territory for me here. I think we'll get there. I'm like 95% confident that we can get there, but I haven't actually done this yet. So I'm kind of off the map here. So if I go through and if I do k8s get deployment Kubernetes dashboard, so Fernand says, can you walk through how you managed to figure this out? What was your debug process? Seems like diving down the onion rings. So yeah, so my debug process is that I actually went into I did a kubectl exec into the auth proxy, and I'm like, hey, can I get there from here? I couldn't get there no matter what I tried. I'm like, well, what would be blocking that? Is my networking broken? But I could get to other things via services. So I was pretty sure that networking in the cluster wasn't broken. And then I thought, oh, well, maybe they're doing network policy. Now, one of the things to keep in mind with network policy is that not all network providers support that policy. So you have to know whether your provider supports it or not. This cluster by default uses Calico, and Calico does support the network policy, so that's what's blocking things now. So what we can look here is container port is, so this thing is, even the deployment doesn't say anything. But if I look at this, the Kubernetes dashboard, which port is, it is listening on dashboard arguments. Here we have I believe it listens on 9090. So this is the insecure port here. And by default, the insecure bind address is 127, but the image that's using actually does 000, right? So what we can do here is that we're gonna go do this, and we're gonna say we want to do port 80. We want to go to 9090. I think that'll work. Let's see what we're going on here. Okay. So now, if I go through, what are you doing here? Am I screwing something up? All right, so now we're going to do some debugging. K8s get pods, and let's look at the auth proxy here. K8s logs. Oh, did I apply? I was doing kubectl edit. So edit essentially brings it up in an editor so you can play with stuff and then applies it. So, so I shouldn't have to apply, I don't think. Lemati says, this may be a silly question, but when would you use the Kubernetes dashboard versus Prometheus? Grafana is one of the... Well, I think the Kubernetes dashboard gives you access to sort of, what's running, what are the pods, what are the services. It's essentially an interactive graphical kube control in some ways, whereas something like Grafana and Prometheus is about sort of like, well, what's actually happening from a sort of metrics point of view. All right, so this thing is essentially saying proxy error context. So things are still timing out, which makes me think that, did I screw up something? So I'm going to go through, I'm going to do ksys exec-t-i. So now I have a bash prompt in this thing. Do I have curl? I do have curl. And so if I look, my upstream from here is going to be this. So I can do curl that. Does that actually get me anything? That does not get me anything. That doesn't get me there. Now, one of the things I can do here is let's try and go to the pod directly instead of actually going through the service and see if that works too. So let's go through. We're going to exec that. And remember, this is port 9090. It says connection refused. Failed to connect, connection refused. So that is interesting. So one of the other things I can do here is I can go to the node that's running that, and let's. So did you modify the dashboard service to add port 80? I did. I didn't modify. I think. Let's. So I did edit the service. So the service, oh, it didn't take for whatever reason. 80. So something went wrong there. Let's see what's going on. I expected this is the dashboard service. So we want to do 80 to 9090, right? Let's go ahead. We did that. Oh, it says error. It didn't like it. Why did it not like this? Ports. Port 80, 9090. Do I have to give it a name? Oh, it's still not happy about it. You need a name for more than one part. We'll go ahead and do that. There, okay, now we're good, okay. Oh, all right, so we're making progress. We're now getting a 502 from something. Okay, so now it's saying port 80. When it's dialing the service, we're getting connection refused. Okay, so let me do that bash thing again. And we're trying to get this so that we're getting connection refused. Okay, so we are getting to the pod. We're trying to actually hit it on port 9090, and then we're getting connection refused there. So I may have the wrong port on the, because I just have that wiki page. I don't know what the real default is. That wiki page could be wrong. And let's try and go to 9090. So yeah, we're getting 9090 there. So let me close that. So Ibrahim, you're right. It does default to 127.0.0.1. Let's go through and let's actually just make sure that we know what we're talking about. So I don't know how much of this is necessary, but I'm going to do kube control, ksys get deployments, ksys edit deploy Kubernetes dashboard. We'll go ahead and we'll do that. And what we'll see here, if we look, boom, boom. Okay, here's the arguments. We'll do insecure bind as 0 to 0.0, and then we'll set the insecure port 9090 just to make sure. All right. What could go wrong? Who knows? All right. I think I looked earlier. I like SSH into the node, and I actually did a PS, and it did look like it was already having a secure bind address at 000. So I thought that was working, but like we'll just really make sure. So this thing is creating the replacement and terminating the old one. So we should be up and running now. And oh man, it's still giving me the error. What am I doing wrong? See if we see logs here. So it says serving securely on 8443, but it doesn't say serving insecurely. I'm not trusting this thing. They probably locked it. What is going wrong here? So there you can see that here's the options. Apologize, guys. I'm trying to figure out what's going on here. So I thought the IP address. So it's insecure says it's using port and then secure port. So is insecure port and port or port and insecure port? I'm so confused. So let's look at the code. When in doubt, read the code. App, I don't know, that's back end. What is it we have? Where do you think this stuff is defined? Source, app, call it back end. Args, that looks good. Builder. Insecure port. So we have a whole bunch of setters on this. It's looking very Java-esque. Yeah, Chris, you need to actually get a one-line fix and come in and help me here. We're going to figure this out, everyone, so don't worry. We got this. You just need to give me a second here. All right, so insecure port is 9090, and insecure bind address is this. So what is going on here? So this thing is running k8s. Actually, somebody's sending me Slack messages. Are they going to give me the answer? No, nobody's helping here. All right, let's see. So what are we doing here? So let me make sure that these things did get through. So we do have insecure bind address and insecure port. That should work. Is there another flag that has to say, no, really, I mean it? Enable insecure login. When enabled, dashboard login view will be shown when dashboard is not served over HTTPS. Oh, I think maybe we have to give that one. So Chris is like, do I need a Diet Coke or string cheese? Yeah, bring me a Diet Coke, Chris. I would appreciate that. So Miyu says, bash into the dashboard and see what bindings are. So I could dash into the dashboard, but it actually has a really minimal image, and so it doesn't even have like bash that I could figure out. So that's something. So the services does have the port, so we do have that. Is it running on insecure, secure? I've missed part of the show. Yeah, so the way that the auth2 proxy Marco works is that it doesn't know how to deal with self-signed certificates on the upstream service. So we're trying to enable the insecure login for the cluster. Oh, here's a Diet Coke from Chris. Thank you, Chris. You're a huge help.
I think it is that flag.
Yeah, I think that we're gonna try that flag. That'll get us there. Okay, so edit. So we're gonna do that, and then we're gonna go and we're gonna give it one more flag. Enable insecure login. We're gonna go ahead and do that, and get pods. Okay, this thing is up and running. Oh, we're still getting the 502 from it. Ksys logs. It's still not saying that it's doing the insecure serving. We're going to have to read some more code here. So that's not the thing. Authentication mode. Meh. Yeah, that's how I feel. Bind address, insecure bind address. So we should be good. What's going on? All right, I think something wacky's going on. So get pods. We want to go to this thing. I have a thing here which is run tunnel. This gets, so I'm now logged into the master. I can SSH here. So I can look. Okay, so here are the arguments to the dashboard. Insecure bind address. So we were doing 000 before. Bind address, auto generates certificates, insecure bind address, insecure port, enable insecure login. Why I ask this is in the address you're using HTTPS. Oh, okay. So the HTTPS is going to the auth2 proxy, so that is secure. It's the link between the auth2 proxy and the dashboard that we're having problems with. Okay, so we do see this is happening here. So this is working. We're hitting port 9090. So we should be able to, so if I do kube control, so I'm now on the master machine, get, so now if I go through and if I do, so let's, oh, wide. So now let's try, so this is this. Now if I do curl, I'm still getting connection refused. So for whatever reason, this thing is not actually listening on the secure. Try another port other than 9090. I don't think that'll do it, Chris. I'll keep that in mind. Let's see what's happening. I'm going to read some more code here and actually see what's going on here, because I think that there might be init the system banner manager, init integrations, create HTTP API handler. So where do I go through? So there are certificates. So let's see. Oh, here's the thing. It does one or the other. If I have serving certificates, it will only serve HTTPS. If I don't have serving certificates, then it does the insecure stuff. It won't serve both of them at the same time. Right, so that's the problem here. So now what I can do here is if I go through, so I never would have guessed that because the flags don't imply that. So now sometimes you just got to read the code, unfortunately. Edit. Okay, so now we're going to edit this again, and we're going to remove the auto-generate certificates, which I think says don't use certificates now. Yeah, so Ibrahim, yeah, it looks like that's the case here. So we have this thing running. Yes! Woohoo! It works. All right, so now the problem is that we're logged in with an auth header. Okay, so this is the problem. So now it won't go through and actually let me. All right, so this is new. So we got to the dashboard. That's great. It's passing an auth header through. And so this is probably a configuration option here on the OAuth2 proxy where, so okay, pass HTTP basic auth, so there's some sort of auth header that gets passed through. Pass basic auth. So let's see. So there's actually a PR for passing through the auth header, auth2 proxy pull 543. So let's see what that thing is. Cisco Spark, that's not. I don't think this is the one that you were talking about. 534. Okay, there we go. 534. There we go. Add authorization bearer jot style headers. Okay. All right. This is, I'm not sure everything that's going on there, but this is So I think this will actually pass it through. Okay, pass authorization header, set authorization header, pass the authorization header to upstream. So that's what we want, but that's not actually working. So let's see. So that looks really cool. Okay, so the container doesn't expose 9. You either are doing secure or non-secure with the dashboard. So that's the problem that we were hitting there. Okay, so we still go through, and this thing is passing some sort of auth header through. And I'm not sure why it's passing an auth header through, but like I think that's the wrong thing. So I think what I want to do, and let's see if we can do here, is that it does have this pass basic auth, set default to true. And so we're going to go ahead and we're going to set some of this stuff to false here. So it's false, and then we're going to do the pass access. I don't know what the default for pass access token is, but we're going to set that equal to false too. All right, what could go wrong? We'll apply that. All right, we have a new one running already. Yes, and we got to the point. So now we can go through, and now we essentially are back to where we wanted to be. Now, one of the things, and this is, I think, is the interesting thing here, is, and this is the next step, but I don't think we're going to have time to do this, is that if we do this pass access token, pass the auth access token to upstream via the X forwarded access token header. So this is essentially, we'll take the access token that lets us verify who we are with GitHub. It's going to let us go through and actually send that through. And then that'll go to Kubernetes, and then Kubernetes will be like, I don't know what the heck to do with this access token. And it'll then send that to any configured webhooks. Now, we don't have any configured webhooks in this thing by default, but then you can have essentially an authorizer or an authenticator that will essentially take that, and then it could call back and verify that with GitHub to make sure that you are who you say you are. And so that way what you can do is you can complete the loop such that when you authorize yourself through GitHub, that authorization flows all the way through. And I think that that ends up being similar. So that gets passed in a custom header. But if you go through and wait, am I looking at the right one here? So there's, but the thing that the one thing is this one. So this is actually saying instead of using a custom header, use the authorization header here, because right now it uses X forwarded access token. This would actually do a real authorization header as you're sending that stuff through. Now I believe. So I believe Kubernetes dashboard access token. I believe I remember seeing someplace. So this is how to do the service account thing. Yeah, so we did that. Okay, let's search the dashboard, because I think the dashboard knows something about the X forwarded access token. Because I'm not the first one to go down this path, even though nobody's really documented it well. Oh, it's in an issue, oversized record received. So this is something. Could not find anything. Okay, so maybe we do need that PR to be able to deal with stuff. Yeah, so, okay. All right, so, okay, so we're not quite to the sort of the Shangri-La where you can actually go through and have your authenticating proxy authenticate you to the, essentially not only let you through, but provide the right stuff so that you can authenticate all the way to the API server. It doesn't look like the right things to do to be able to do that are there. So yeah. There's this Kubernetes OIDC helper. So if we had that, you could go ahead and, okay, we could actually set up oh, you don't actually need the webhook thing. You could actually set this up with Kubernetes itself and it would pass it through. So if we had this, we'd actually be in really good shape. But I don't think it's quite there yet. All right, so maybe next time, maybe this stuff will make its way forward and we'll be in good shape. But I'm actually pretty excited about this. Now here's the thing that I want you all to realize is that we set this up for the dashboard, but this same technique for setting up this sort of secure, screen door, right, or secure gate could be used for any sort of internal dashboard. So you might want to set this up for your monitoring dashboards. You might want to set this up for your like Jenkins that you might be running on the cluster, all sorts of things that you can do something similar for this. And I believe, now I haven't actually done it, I didn't want to complicate things, but I believe that, oh, that's wrong. So if we look at the auth2 proxy, I believe the way you can actually set this up such that I believe you can set this up such that it actually can deal with a whole bunch of backends, right? So you can deal with multiple backends, and it uses like the host header to be able to do it. I don't know how smart this is about sort of letting you auth once and then letting you access a set of services. You might be able to do something like, multiple levels where you have this then talk and then you have this go back through maybe another ingress controller for internal ingress or something. I don't know. So that's an interesting thing because we just did a one-to-one between the auth2 proxy and the dashboard. I don't know if there's a way to do sort of a one-to-many with the auth2 proxy and a bunch of stuff that you might have on the back end. All right, so I'm going to read. So Sean says, guess I'm misremembering. Must have watched a different video on autoscalers. My bad. I did do one on, I think we might have done HPA. I don't know if I did horizontal pod autoscalers. I don't think I did an episode on that. I'm a little bit like everybody loves autoscaling, and my take on it is that it's really finicky. Whenever you do autoscaling, you assume you know where the bottleneck is in your application, and for any complicated application, your bottleneck usually isn't where you think it is. And then Jim says the authentication documentation days says there's an issue with OIDC authentication for dashboards since they're so short-lived. So yeah, we're not doing OIDC authentication. So if you did that, yeah, you'd have that 15-minute token. We're using the long-term JOTs for the service account here. So we're just using the OIDC as a front door. If we did go through and we use the OIDC thing to be able to do this, then it would be up to the proxy would actually be doing the refresh and passing a new access token for. So if we got this set up and this proxy was passing things through, we'd be in good shape. We wouldn't be dealing with that. So there were a couple questions earlier about whether the Google Identity Aware proxy works with GKE. Yes, it does. That's what Brandon's saying here. And then Marco says, am I connected to the chat? I love my internet. You are connected, Marco. Did you say something? Chris delivers. Yes. All right. So that's it. I'm happy with where we're at here. I have to tear all this down because I exposed all sorts of secrets. What I'm going to do is I'm going to put all the links here. But I'm also going to make sure I upload this big YAML file with the auth proxy. Y'all can look at that. And then I'll include my notes here too, which has a bunch of pointers to stuff, including that one-liner for creating the secrets that's necessary there. You meant Moody says the Kubernetes cluster autoscaler. Okay, so the Kubernetes cluster autoscaler is interesting because I haven't used it myself, but it has to sort of have a sort of a deep sort of integration with the underlying way that you provision nodes, right? Because that if you want to scale up the cluster, you have to say go through and adjust the Amazon autoscaling group that actually maintains a pool of nodes, and that level of integration makes it difficult for the cluster autoscaler to be super generic. But if you look at the cluster API, the way that the cluster API is modeled is that you wouldn't use, and I did an episode on the cluster API. you wouldn't use the underlying cloud provided sort of auto scaling mechanism to be able to drive the size of your cluster. Instead, what you do is you actually create a pairing so that you have like a machine object, which is a CRD in Kubernetes. Then you have a controller that knows all the guts on how to talk to your cloud. The controller creates nodes on demand based on the machine object. And then the autoscaler actually knows how to create and delete those machine objects that then cause downstream things to actually be created or not. So I think the future of cluster autoscaling is going to be something like the cluster API being a basis there. So that's something that I would look at. And then, yeah, with spot instances would be super cool. Yeah, so the combination of Kubernetes and spot instances is super neat. All right, that's all the time we have for today, folks. I think, I hit an hour and a half on the nose, but then I kept talking, so almost there. But thank you, everybody, for watching, and hopefully you all got a lot out of this. Stay safe. Don't expose your dashboards to the world, whether it be the Kubernetes dashboard or Jenkins or anything else like that. Hopefully this gave you some ideas and some techniques that you can use to keep yourself safe. But see you all next week. I have no idea what I'm going to cover, but we'll cover something interesting. All right. Thanks for tuning in.